Good evening, everyone. We're back. We're back with CAP 161 Module 2.2, Drafting Paraline Drawings. This is a companion to our previous lectures of multi-view drawings as well as an introduction to the topic, but I just want to take you through a few more examples so we understand the terminology and what we're doing for Module 2.2 as we complete this multi-view drawings unit, doing some great drafting work and great measuring work and understanding our objects really, really well. So let's take you through the Module 2.2 brief. Let's review some of the terminology once again. Isometric drawings versus oblique drawings. These are part of the category, contained in the category of axonometric drawings and Paraline drawings as defined by Ching. Some other examples beyond Ching, looking at the comparison between these two different types of drawings. My good friend Jim Leggett, who wrote a wonderful book called Drawing Shortcuts, will explore that book in greater detail in other courses. We use it in my Short Graphics elective, and it's a great studio companion. But you can see that a plan oblique, if the plan is the oblique and we're creating an oblique projection off of the plan, what Jim does is he takes the site plane, he rotates it 30 degrees towards from the parallel bar. You can imagine there. This rotation of the plan 30 degrees up anti-clockwise, as you can see, and then he projects up at true length or scale length the height of trees, the height of pavilions, the height of structures, the heights of buildings, continue to give more of a site plan view at more of that looking down. It's very similar to drawing a site plan or a floor plan, but it does give a little bit of projected up. So that our public can understand three-dimensionality and massing and trees against each other. When we draw isometric drawings in landscape architecture, urban design, urban planning, we draw them so that we can see more of the sides. The two sides are two elevation views, and start to see architecture in a context with landscape elements and things like that. It is a very different drawing in the sense that we tend to see more of the sides of things as opposed to the tops of things. So oblique drawings are really good for looking down into something. Isometric drawings are really good for looking at the two sides. Oh, bless you. I'm going to have to edit that out. Oh, mercy. Going back into Frank Ching, some of the drawings and diagrams that he has in his book, companion to the multi-view drawings, the plan, the section, the elevation. This isometric drawing here is a reference to all of the measurements that are contained within a multi-view drawing. If we look at these elevations in this overall plan, he marks out all the different measurements that are referenced. When we make an isometric drawing or an oblique drawing, everything remains at true length. That's very important to remember, that everything remains at true length. But there is some distortion in the sense that these angles are projected a little bit differently. That the floor, if you will, of this cube is in fact foreshortened in an isometric view. In an oblique view or plan oblique view, it remains true. We'll see more examples of what that means later on. But as you can see, the drafting triangle, the 30, 60, 90 drafting triangle, is a handy tool against the parallel bar to start to construct these. If you have a parallel rule, you have a protractor on the parallel glider or the parallel rule that you can actually set it up as well. So the parallel glider and the parallel rule is a tool that has a protractor on it. You can actually set up those angles as you continue to draw. But very important to remember that in these types of drawings that everything does remain true length. So we often use isometrics for small detailed views in landscape architecture, urban planning. This example here, the parking court, but the floor plan does not represent true plan view. The square corner here, as you can see, is distorted or foreshortened. But the width of the sidewalk and the length of the sidewalk pad and the tallness of the tree and the proportions of the cars, all those remain true length. So that's important to remember. There tends to be a more balanced emphasis to the sides and top view as opposed to favoring the top view. Lines that are parallel to each other in life remain parallel but not perpendiculars, and the same 30 degree angle for sidewalk and parking spaces occurs there. You can see that 30-30 relationship right there in that particular segment of the sidewalk. So these are really loose, wonderful drawings from my good friend Jim Leggett that we use in design charrettes and in public workshops because they can be accomplished in the field, and the public really does respond to this loose type of drawing because it means that the design is still very much fluid and not necessarily set in stone. Isometrics are also good for larger urban planning, urban design context drawings. If we're looking at a growth plan for a region or for an area, this isometric view, which is probably 30-degree triangle once again, helping to make that. But again, it does give us not necessarily a true overhead view, but it gives us more of a bird's eye perspective, a bird's eye kind of angle to which we can start to see the relationship of open space to buildings and to streets. It does work very well for planning out larger segments of urban blocks and urban districts. So it's a good drawing for that type of purpose. So we can also layer trace paper on top of each other and start to show the growth over time of a particular neighborhood with this isometric view. It's really nice to be able to show phased construction or phased growth in this view by just simply placing another piece of trace over the previous one and continuing to build up the drawing. So in a design charrette or a community workshop, we often use drawings like this to show phased growth over time, because the public reacts more to the side view and relationship to the site and to streets. A lot of folks can't read plan, and so consequently this drawing type really does work really well in public settings. We can see that a 30-60-90 relationship is evident here. Probably two angles or two usages of a 30-degree triangle here, in fact a square corner in an isometric view is going to be a foreshortened or distorted segment, as you can see. That if this is a true square in isometric view, you are in fact looking at a diamond shape, and it does have a type of foreshortening or distortion. Here's one of my drawings from a few years ago, looking at a little riverside town here and looking at options for surface parking for this particular structure. I believe it was a courthouse or a city government of some kind. And the isometric view was really helpful because it allowed me to layer in options for a site. So as we click back and forth between a structured parking option or a surface parking option for the drawing, it allowed me very, very quickly to lay over another piece of trace, sketch in another possibility for the property, and then be able to click back and forth between the two views. We can set up PowerPoint shows or animations to show these different options for the public. So again, a good drawing type to show the relationship of buildings to spaces and the landscape, as well as see more of the sides of things as opposed to just the tops of things. Isometric view is used across gaming and across computer software. It's a very standard view for presentations because again, it gives us better insight to how the architecture or the landscape architecture or the city plan comes together, because we can see the sides of things as opposed to just the tops of things. They're also really good for cutaways. There's some really, really beautiful examples of isometric drawings that have cutaways or portions cut away so we can see inside structures. And this representation here of the Duomo in Pisa, which is very, very right next door to the Leaning Tower of Pisa, a cutaway portion of the drawing can actually give us more insight into some of the aspects of the architecture. And again, with computer software now, we can the isometric view is a very standard view that we can often start to generate some really explanatory diagrams, overall growth plans, infill, using color coding and symbols and shapes and landscape materials to start to delineate public spaces and active streets. The isometric view is still very, very valuable for us to communicate all these different complex issues in the built environment. Looking at some examples of oblique drawings, in the oblique view orients the plan or horizontal view parallel to the picture plane, which allows that plan view to be represented true scale and in true measure. This plane is typically rotated off of 90 degrees if more than one plane can be depicted in the same drawing. So look at this cube. This is very different than the isometric view, and we can see that this portion of the cube remains square. we could see that that has a square corner, and then these three segments here remain the same length. Everything still remains true length, so all the projections up remain true length, so that doesn't change. But the whole thing has been rotated against parallel, so we could see a 30-degree angle here and a 60-degree angle here. Pretty typical view, but not always the case for plane oblique types of drawings. More examples from Ching showing different oblique views and how different triangles, either favoring the 30 or using a 45, 90-degree triangle, or the 60, leads to different views of cubes. And so making those decisions are important when you're starting to set up the drawing. Plane oblique, again, very, very similar. If you turn your head just a little bit, there is a 30-degree turn to this particular plan, and then in the case here from Jim Leggett's book, he projected up. So you can see the shelters here for this light rail stop were projected up. You can see the height of trees is projected up. You can see the height of the light rail vehicle also projected up. So simply, it's an interesting drawing and a very easy drawing to make, in the sense that we just take the plan, site plan, turn it at an angle, and then we're able to project all these elements up and then quickly render it. It's another good way to represent complex sites, in this case, in a public setting. Plane oblique is also good for cutaways. Here's an interesting example from Ching's book, in which he's able to show portions of the floor plan of this particular church and then cut away the rest. And so putting these drawings together and layering them together, collaging them together, can be a really, really fascinating way to study architecture, because you're able to see more than one representation of a building at once. And so it also helps us start to fuse these different ideas in our minds, so that we aren't experiencing architecture just in plan, or just in elevation, or just in section. When we actually start to put these drawings together, man, you just get a clearer understanding of how the building actually goes together, and how the spaces are linked, and how all these different geometries start to come together. Very interesting to me how Frank Ching has decided to put these different drawing types together. The modernists also did fantastic drawings, going back into the 19-teens, 20s, and 30s, as modernism started to take hold in Europe. Some of the beautiful drawing types, typically ink on board, matte board, and often painted with gouache or watercolor. So some really beautiful drawings from that era of early architecture, 1900s, 19-teens, 1920s, 1930s. So if you're interested in that early portion of modernism, there's some wonderful books and references in our library about this era of Dutch, German, Swiss, and French modernism. We can see that this oblique drawing is set up with a 45, 90 triangle, and then the opposing 45, 90 triangle, and that square corners do remain square. So that's important to remember, as we see 90 degrees remains 90 degrees, and everything remains true length. So this type of oblique drawing uses the 45, 90 degree triangle to build up the representation of three-dimensionality from the floor plan itself. This example from Gerrit Rietveld, one of my favorite houses in the world. I've been able to take students there twice. It's in Utrecht, Netherlands. It's called the Schroeder House, later called the Rietveld Schroeder House, because Gerrit Rietveld, the architect, was, well, having a relationship with Truus Schroeder. So this drawing here, probably a buildup of gouache, which is an opaque type of watercolor. Buildup of line, buildup of pencil. So you can imagine him drafting this on his drafting board, and then carefully painting these layers of color, of translucent color and of opaque color onto this. Really fascinating drawing type that we often mimic, if you will, in Adobe Illustrator today and in software programs. But this house is really interesting, because it's oriented very much like a tree. It has a center trunk, and then it has branches off of it, in which four distinct zones of the house branch off from the center staircase. And then there's all these wonderful openings to the outside, these walkout balconies and windows that extend the space from the inside out. Fascinating house. I do recommend studying this house in greater detail, and if you can, visit Utrecht, Netherlands sometime in your life. But if we look at that drawing there, it's done with a 30-60-90 triangle oriented on two sides. This is the 30-degree side, this is the 60 side, and with a square corner in the middle. So it is an oblique view projected up from the floor plan, rotating the floor plan 30 degrees to parallel, and then using triangles to project up the height of walls from the floor plan to make a very interesting three-dimensional style of drawing. Peter Eisenman, who is still with us, he is a very storied and very accomplished architect, doing a lot of work over the past 50 years. You may be familiar with some of his work. The closest building to us that of note would be the Department of Architecture, Art, and Planning down at the University of Cincinnati campus. Some of you may be familiar with that particular campus or that building, but he uses the axonometric drawings and obliques in particular to do series of geometric studies that led to a series of houses that he built early on in his career in New York and Connecticut. He was also part of a group of architects called the New York Five, who really used geometry and principles of modernism to really put forward a great series of contemporary houses and contemporary buildings from the late 70s into the 1990s. So if we look at drawings from his firm and from his practice and from his drafting table, we see some great examples of this type of drawing, because it gives us an insight into the scales of spaces, gives us an insight into the tallness or height of columns and walls, and this particular viewpoint allows us to sort of look into the house, and so setting it up with a 30, 60, 90 degree triangle and keeping the true corner down in the corner there, and basically taking the original floor plan and rotating it and then projecting up from it gives us great insight into the nature of the spaces by being able to look down into them. We can also start to see different materials and line weights that he's using here, different line weights to create emphasis for windows within window frames, different emphasis to emphasize column tops. Here the line weights are starting to communicate those differences, and then thinner line weights to represent flooring material or tile in the case here of floor coverings and the like. So some really beautiful drawings from this particular era of 20th century architecture. Again, 30, 60, 90 degree triangles set up on two sides, and then the square corner in the middle allows this view to allow us to see the house in this particular way. He also uses this to show process in terms of how he starts to think about space and create geometric divisions, the use of axes and datum lines to start to create zones in the house, and start to place elements like columns and walls, chimneys and furniture around that particular grid. So a very intense series of studies for these early houses, house 1, house 2, house 3, house 4, all the way up to house 10, for a series of clients in the New York area from this time. And so these particular studies are really interesting for us as students because they are reminding us of some of the ordering principles, grid, linear, datum, transformation, those sorts of things. They are very reminiscent of those different organizational systems. He uses the drawings also to communicate different material types or different zones or even different equipment, the location of walls, the location of cabinets, and the likes. And so this type of drawing can be very helpful for isolating one material type or one component type from another. Great series of drawings from House 4 showing transformation. So, there's one of our organizational systems, and so these drawings came together here to show the geometric division starting from the cube and then dividing it all the way down to the specific design ideas for the house. Replicated here with the models, although these are definitely perspectival views of representations of the model. But if you compare it back to the drawings here, we can start to see see a little bit of the mind of the architect, if you will. And here's a more detailed finished model of House 4. House 4 was never realized. Other houses closer by to us, two houses by Michael Graves. Michael Graves is a Broad Ripple native. He grew up in the Indianapolis area and early on in his career built two houses in Fort Wayne in the late 60s, early 70s. The Snyderman house was completed in 1972, but sadly was destroyed by arson in 2002. But the drawings from the Snyderman house are fascinating because they really do give some wonderful insights into the mind of the architect and into the project itself. Very sad that this particular house was destroyed. It's hard to imagine, if you will, hard to believe that this was destroyed by arson, but great loss for the Fort Wayne architectural community. A lot of folks were fighting very hard to preserve it before it was destroyed, but unfortunately this house is no longer with us. Thankfully, though, the Hanselman house is still around. It is on the south side of Fort Wayne. If you want to visit that particular portion of Fort Wayne and check it out, it's a very fascinating house, now available as the Cube House from Airbnb. So if a few of you want to someday stay overnight at the Cube House, formerly known as the Hanselman house, that is available to you on the south side of Fort Wayne to be able to spend the night in a modernist masterpiece. The former Hanselman house is available on Airbnb. Other studies from other members of what we call the New York Five, Richard Meyer being another, Michael Graves being one, Richard Gluckman, and a few others, often using these drawing systems and these pictorial systems to represent different materials, different massings, and different portions of the architecture. Really fascinating sets of drawings. Getting into context, this is one of the original drawings for the High Museum of Art in Atlanta. If you ever visit Atlanta, do check out the High Museum. Really fascinating museum campus. There is a new addition over here by Renzo Piano. But this particular drawing is starting to incorporate some of the context. And so the relationship to the street, the relationship to other buildings, the relationship of other streets, really good type of drawing to show an overall view of the architecture sitting in context. Another type of drawing that we went over in the previous lectures, but it's called elevation oblique. That's where the elevation remains true and we project backward from it. So very interesting drawing system that's elected to be used by some architects and designers because of its ability to show different layers, spatial layers. So we can see probably section cut here, and then a forecourt, and then one facade, a second portion of the facade, an interesting roof terrace here, and then another facade. If we were just to look at all these in elevation, they would just appear as one building. But in elevation oblique, we're able to show depth, and we're projecting backward from this section cut in true length. So it starts to show more of the intent of the architecture as being more of a terrace. And so it's a drawing system or a drawing type that can really show layering very, very, very well. Here's an artist, designer, architect named Emily Russell. From her website, she uses a combination of cut section here and then oblique projection to represent this complex office building. So you can see the portion of the cross section here, and then using elevation oblique to project back from it to display the intent and depth, and even starting to get more into some of the site elements that are occurring as well. Fascinating set of drawings.